Hi, everyone. Welcome to this second day of Cyber Science 2021. My name is Pierangelo Rosati. I will be the MC for today's session. I have the pleasure to have with me today Dr. Legg, Phil Legg, Associate Professor in Cybersecurity at the University of West England, who will present us his paper titled Hacking and IoT Home, New Opportunities for Cybersecurity Education, Combining Remote Learning with Cyber Physical Systems. So, Philip, with no further delay, I'll hand it over to you so we make the most out of this session.
Excellent. Thank you very much. Let me just bring up the slides. Okay. Is that visible for everyone? Is that okay?
Yeah.
Yeah, excellent. So good morning, everyone. Thank you for joining us for a session. Thank you for the organizers for welcoming us to Cyber Science this year. My name is Dr. Phil Legg, Associate Professor in Cybersecurity. I'll be presenting our paper on Hacking and IoT Home, New Opportunities for Cybersecurity Education, Combining Remote Learning with Cyber Physical Systems. And thanks also goes to my co-authors on this paper. So two of our former students, Thomas Higgs and Pennie Spruhan, and also two academics, Jonathan White and Ian Johnson. Okay, so just a brief about myself then. As I said, Associate Professor in Cybersecurity. I run our NCSE certified MSc in Cybersecurity. I'm also the co-director of our UE Cyber Academic Centre of Excellence in Cybersecurity Education. So that's obviously what we're going to be looking at today. My research interests around cybersecurity, machine learning and data visualization, how these three interact and interlink with each other. And in particular, looking at things like insider threat detection, cyber situational awareness, adversarial AI, and cyber resilience. Okay. So in terms of cybersecurity outreach, so obviously within the university, we've got a number of different hats that we wear in terms of teaching and learning, research, and outreach and engagement is a very big area that we focus a lot of our work on also. And as I mentioned, being an academic centre of excellence in cybersecurity education, one of the kind of remits that comes with that is this focus on how do we promote cybersecurity as a future career path to schools and colleges across the region, working with those, introducing children and young adults to the opportunities that are available there. So we've held a number of large-scale workshop events, school visits and clubs, university taster days. We run every year an Unlock Cyber event, which sees about 300 Year 8 students descending on UWE's campus, getting involved, working with industry and academics on various challenges and activities. Again, just trying to inspire and entice them into technology, computer science, and cybersecurity. And just a couple of the examples that we've done over the last couple of years. There was a National Cybersecurity Centre event called Empower Cyber back in November 2019. And we hosted a Severo challenge. So you can see on the right-hand side here, in this blue-looking hall, we had 800 Year 8 girls turning up to work on all sorts of activities. A very chaotic day, very exciting day. Students had to learn how to program a Severo robot to walk around a maze, and then other students had to try and essentially intercept their robot to make it crash off the course and hack their robot, so to speak. And then we looked at other kind of activities we could do. Again, there through some of the discussions with folks such as Cyber First, we were running a Scalextric scoreboard hacking activity. It's actually took inspiration from the 2014, I hope that's right, 2014 Olympics, whereby we were actually discussing with people about the cybersecurity issues around the technology being used for the scoreboard. So you've got an international global event such as the Olympics, you've got a scoreboard reporting what's been happening. You don't want anything to go wrong with that scoreboard. So that's actually where our Scalextric activity kind of originated from. And what we had here was essentially students setting up a Scalextric that had a little little motion sensor to be able to recognize when a car goes past, that was then linked up to a Raspberry Pi, and students were able to work through worksheets to be able to gain access to that Pi, be able to see what's running on there, and it's a web server essentially. Being able to see the database that's driving that website in the background, and then be able to essentially change the values, compromise values. You might set it so that every time the motion sensor is triggered, you add 10 laps instead of 1. You might do it so that you reset your opponent's score to 0. And it was very much a kind of two teams hacking from their laptops this scoreboard that was central to it all. So whilst some of the team are racing the cars round, the other members of the team are basically sabotaging their opponents. And it's all good fun. And it really, really has been fascinating to be involved with, to inspire and encourage kids into technology careers. But also, there's a lot of technology being taught there in terms of Raspberry Pi and embedded systems, Kali Linux, Nmap, Hydra, Python, packet capturing and spoofing, and all these kind of concepts which you give them the engaging thing and wow, this is cool, we're playing with scalextrics. And then you kind of reverse engineer it and you say to them, oh, well, do you realize that actually you've done network mapping, you've done Hydra and password brute forcing, and all of these things that they had to do along the way to solve the challenge. And another thing we've got at UE is this physical space, which we call the Cyber Foundry, which has a bunch of IoT gadgets. We've got an IoT workbench, a industrial control system, simulator, various other kits that we've been wanting to get students playing around with. But what happened? COVID-19 happened. Okay, so we had a lot of activity at the start of 2020 happening in terms of schools outreach and engagement, these scalextrics challenges, students taking these projects into schools, and all of it came to a stop. And actually, it was a real shame, obviously. It's obviously been a very challenging year. But for all of the students who are very excited to get involved in these things, and then suddenly being told, oh no, actually, we've got to stop it, it can't happen. So there was the challenge then posed to us. We wanted to keep doing outreach and engagement. How do we continue to deliver outreach opportunities during lockdown? And also thinking about what are the new ways of working that we need to think about. Obviously, we've never been in a pandemic before. It's made people change their way of thinking quite a lot over these last 14 months or so. I mean, you've only got to look at a conference like this to know that, rather than us all being in Dublin this week. So there's a lot of changes there that we've had to think about. But also, we don't have physical access to our kit. All of our staff and students are at home. So how do we build something that is going to work effectively, but also offer that same level of engagement and excitement that we'd seen before? So what we looked at developing was a workshop called Hacking the IoT Home. Okay, and this is something that can be delivered remotely. So it's based on capture a flag. Okay, so the concept of perform an activity, you get a little passphrase, and that can then be entered into a web browser or some text entry, if you like. And the nice thing about capture a flag exercises, as many of you on the call probably know, they really can be anything. Anything where you've got the student to perform some sort of activity. On completion of that activity, a flag is provided. They enter that in, and they get their medal or certificate, whatever it be. But there's a lot of things out there already that do this. I mean, Immersive Labs, Try Hack Me, Hackerbox, fantastic platforms for those who want to go off by themselves and, self-study, get involved, do a task, get their CTFs, their flags, and teach themselves. And that's really good. But a lot of that is, self-driven, self-motivated, doesn't really have that kind of team element, doesn't really reveal anything happening, like the scoreboard example or the Sphera example. So what we did was say, well, hold on, how do we make a CTF a bit more interesting in terms of seeing things, you know, blow up or whatever? So we linked it to IoT, okay? IoT device control. And so what it means is that we've got remote control of physical devices. And of course, we've got online video. So actually students can observe what's happening via their online videos. Okay, so they join a call and they can see what's happening. And the idea behind this was that the CTF IoT server that drives all of this, it can be deployed on a Raspberry Pi. It's cheap, okay, cheap and affordable hardware. A lot of schools have Raspberry Pis. And also importantly, it's separate. You know, we're not saying run this on your main computer, you know, because, you know, if we're essentially allowing students to access it, we want to make sure that's contained and separate. So we essentially say, right, we've got a Raspberry Pi. You know, here's one sat by me here. I've got it all loaded up on a Raspberry Pi. I can just drop that onto a network and begin playing around with this kind of activity. Okay, so what does it require? As we've said, Raspberry Pi IoT CTF server. So this is the application that working with our students we've developed. Webcams. So again, got lots of webcams knocking around here that we use. IoT devices. Again, a lot of people at home will have things like light bulbs and switches and various other bits and bobs. As we were showing earlier, we've got a lot in our lab. Unfortunately, we've not been able to use our lab, so we've had to kind of make do with what's essentially at home. And the important thing here is that these are running on a 2-year network, and I'll talk about 2-year network shortly. And there is a little bit of home networking knowledge required here. Essentially, the most we do is on our main home router is be able to say forward all traffic to my Raspberry Pi web server that I'm running. Okay, so again, yes, we are opening things on a home network, but we are pointing everything at the Raspberry Pi. And again, that's why it's very important that we've got this separation of the device. But really, we're trying to just create something that's relatively simple to set up, that, you know, once we've been showing this to teachers, they might say, well, actually, you know, I fancy having a go at creating my own one of those. They can go off and imitate that. And so it's a small Python Flask server. So Flask allows us to run Python as a web application, essentially. So we can host a web app, simple page where students can enter a flag. But the important thing there is that it then talks back to the server, which will then link with the 2-year network in order to control the devices which are set up at home. So in this picture, you can see, you know, there's a light bulb there, there's a fan. That fan's connected to a smart switch. There's also, you know, other areas of my house which are dotted around, which are part of a surprise for students. I'll talk about that shortly. So this is the kind of thing that they might see. Okay, so quick and simple exercise, play along at home if you so wish. The challenge is code breaker. Can you decipher code? So you can imagine, you know, this is displayed on a web page for the students. And of course, if the students are stuck, we'd say, well, you know, why not visit CyberChef? So CyberChef is a well-known online tool for being able to do code breaking. And if they enter this and they select the magic option, it'll actually tell them what kind of encoding we're using. So this is just decimal encoding of ASCII characters. So here we've entered it into CyberChef. We've used the magic. And you know, the important thing here is that even at a very low level, you know, if they don't have all the knowledge about the different kind of encodings, the magic one's nice. It basically goes through all possible options to say, well, which one is it most likely? And they're able to say, okay, well, it matches the from decimal and it gives us this flag here. Okay, so then, yep, just to zoom in on it a bit more, we can see UE and then curly brace robo underscore go. Okay, close curly brace. So, okay, that sounds like an interesting kind of flag. I wonder what that might do. The whole point is that they'll go onto their web page that we see here. They'll type in the flag. They've got their online video as well, and they might see something happen. Okay, so as the name suggests, it might make a robot of some sort go. Okay, What's happened here? Yeah, there we are. So they've entered UE Robo Go, and then it's for them to watch the video. So we hosted a small number of pilot studies on this. First of all, back in summer 2020, we also did another one in March 2021. So we showcased this as part of the CISI UK Practical Ways of Working workshop back in 2020. And as I say, through some other engagement studies in March 2021. And this was really seeing what students make of this, what teachers make of this, how might this change the ways that we think about workshop delivery in the future. And students thought it was cool that they were able to control devices remotely. And the important thing, I guess, to focus on is they could actually see things happening in someone else's home because of what they were doing. And this is actually a really, really key point here, because one of the main things about cybersecurity is really that we're in an interconnected world, if you will, and something that someone does in one place will have an impact or potential impact on someone in another location. And that's something that in a classroom we've never really been able to convey properly. You might have two virtual machines side by side, and I can do something on this virtual machine that impacts the one next to it. Well, I'm sat physically next to it. Of course, I could just go on it and do something myself anyway. So trying to actually convey this idea that a student is controlling something remotely is actually a really, really powerful concept when you're talking about the scope and the reach that cybersecurity actually has. When you think, well, actually, that person could be on the other side of the world, and you doing something has made something happen in their home. So it's turning work from home into an advantage. So we were sat there initially thinking, oh, we don't get to be in our lab playing with all our cool kit and everything. Well, we turn our home into the lab. We say, this is the lab. Yep, okay, I've only got a light bulb, a fan, and a robot vacuum cleaner. But we can make do with that. We can actually turn that into the home that somebody will hack. And so it increases the online engagement and interactivity. May encourage further subject exploration. But the important thing is that through the online video, the students are getting that feedback. They're getting that sense of, oh, I just made that thing happen. And that's really what we're trying to capitalize on with this workshop. So I mentioned the 2-year library. So a lot of IoT devices, if you go on Amazon and basically search IoT anything, you'll probably find something. So there's a lot of generic electronics manufacturers out there, let's say, who are saying, oh, well, this is IoT enabled. And what they do, a lot of them will use the 2-year network because it's basically an existing infrastructure, which then developers can add their own existing kit into. Okay, so it's actually very flexible. A lot of things work on it. I mean, if you've got light bulbs and power switches, the likelihood is, unless they're proprietary, things like Hive smart plugs or Samsung Home Hub or all these kind of things, if they're kind of non-branded ones, the likelihood is they're using the 2-year network. And TinyTwo is a Python library which allows you to interact with this quite nicely. So lighting, bulbs and strip lights and plug sockets, they work really well. And actually, if you go on the project website, which I've included here, you'll see quite a lot of documentation about those. It gets a bit interesting when you start looking at other devices. So I mentioned about the robot vacuum. So here he is. This is Jeffrey, who goes around our house most mornings. Jeffrey, or I should really say the robot vacuum cleaner, he is not documented on the TinyTwo website. So it doesn't say anything about controlling these. So you have to do a little bit of playing around with this. But actually, when you query it, it just comes up with a device that chucks you back a JSON string. And then you can start playing around with those parameters to see, well, actually, how can I trigger a response here? How can I send a request which is going to make the robot move in a particular way? So that's basically what we did. We built a web application so that when particular flags were provided, it would send these requests that we've essentially reverse engineered to the robot vacuum cleaner in order to control it. Okay, and again, as you saw, we've got this view waiting, and the anticipation is what's going to happen in that view. The robot vacuum cleaner comes through, but we want to link this with more devices. So we've got IoT kettles, heating controllers, all various other bits and bobs in our lab on campus. And for the most part of the year, these have been locked away. We haven't really had the opportunity to get back in there and get hands-on with this kit. So we really want to turn something like that IoT workbench into this kind of online remote access interactive space where we might run a session with a school where they can actually control all of the different things on those shelving rigs. Okay, and you can see a bit of the Python code here for being able to set brightness and all the rest of it of the bulbs. So that gives you an idea of how it's coded up. Okay, so what have we done then? We've developed suitable immersive online workshops. Okay, different to existing offers, and that was really important. When we're thinking how do we carry on doing things online, it wasn't just a case of saying, oh well, I'll tell you what, we'll just run a try hack me workshop or immersive labs workshop. I mean, those things are great, but they exist. Those are already existing things which we support students with. But we wanted to try and think, well, hold on, what is it about the physical space and the scale electrics and the Sphero and all that kind of stuff that works so well? And how do we try and start to do some of that online? And that was the key thing here. It was about how we can do something that's CTF based, for instance, as we've said, but that has this kind of cyber physical interaction, so that they perform a request and they actually see something happening. And again, as I've said already, we've got the cameras. We've all learned to work with cameras a lot more over these last 14 months. It makes sense to be able to broadcast some sort of feed to say, right, this is what you've changed in the scene. We ran a challenge with one of the schools where basically they had to see which team could change the light bulb to red or blue first. And again, they worked through a set of challenges to get that final flag to either make it red, either go blue. And that was quite a nice challenge, and introduced that kind of time element as well, because they had to change it before their competitor did. So that was quite nice to do. And I've emphasized this point before, but it is worth saying again. One of the key things about cybersecurity has always been, I can be sat here and I could effectively communicate with something on the other side of the world. And that's always been a hard point to kind of convey in a classroom, especially when we say, right, we're going to run an example where I've got a VM here and I've got a VM there, and I'm going to get that VM talking to that VM. And you're kind of like, well, yeah, I'm sat next to both of them. What's the deal? So being able to think of how do we capitalize on this idea that I can be doing something here. I could be, working with schools in Bristol, but I could also be working with schools in Newcastle or wherever else across the country. It is great that these restrictions, what started as a restriction in some ways has actually created new opportunities. So there is a question then that we think about here of how do we design teaching experiences that capture their imagination in this manner, that actually capitalize on the kind of lessons that we've learned from this year. And that's something that I'll be talking about again later in the week. But for now, thank you very much for listening. If you're interested to know more about this, on Thursday at 1 o'clock, there'll be another session that I'll be leading where I'll actually be giving some live demos on the Hacker House tool and also some of the other tools we've done in terms of promoting online engagement and teaching, and how actually, as I've said, from the things we've been doing this in the last 14 months, how do we learn from those to be able to deliver a better teaching experience as we go forward. So thank you ever so much for listening. And if there's any questions, I'm happy to take them.
Thank you very much, Phil. We have a question here. It says, fascinating talk so far. As part of your work, did you find that most IoT devices are basically easy to hack and lacks basic security by default?
So yes, I mean there are a lot of devices which are quite weak, especially since, as I say, a lot of these third-party devices all rely on this same underlying backbone infrastructure, which is this two-year network. So if you find a means of being able to compromise the two-year network, you can compromise a lot of devices in that way. Having said that, it's not quite as straightforward as that, because there are some keys that you would need to know about a specific device. But again, they could be brute forced quite easily. But yes, I mean, and there's obviously other studies which have looked at vulnerabilities in IoT devices. This is a slightly different one in the fact that we've kind of created the vulnerability in a way, so it is a slightly synthetic situation. And that's obviously a very important bit, because what I don't want is a student gaining access to the machine that I've purposefully opened up to then exploit the rest of my home network. So we've had to be very careful how we explain that one to teachers. But yes, I mean, there are a lot of third-party vendors using IoT devices, developing IoT devices that are hinged on this backbone network. So if there's a vulnerability in there, there's a vulnerability across a lot of devices with that.
Right. Unfortunately, we run out of time because we are on a tight schedule. But just want to say, it would be fun to see what happens when you sell the house, or if you move and then you leave the use case up there for students. I think that would be fun, wouldn't it?
Absolutely. We've had cases where the robot's just been running around the house and dragging the toilet roll around everywhere. So it's interesting to see what you come back to.
All right. Thank you very much, Phil. See you again on Thursday. And then thank you very much for your contribution today.
Excellent. Thank you ever so much. Bye for now.
Thanks. Bye.